Alright, in this video I'm going to be looking at solving logarithmic equations. So we've done solving exponential equations, so now we're looking at log equations. Before I jump into these problems, first thing that you need to know is there's an important property that says if you have log base b of x is equal to another log base b but a y, whereas, see, notice how we have a log with a base b over here, log base b over here. So if we have two logs equal to each other and the bases are the same, then what the property says is whatever you're taking the log of, so in this case x, would be equal to y. So when the bases are the same, we could say those are equal to each other. So down at the bottom, I'm going to solve each equation, and then we're going to check our answers when we're done. So I have log of 4x minus 5 is equal to log of 2x minus 1. So the thing I notice here is I first start looking at my logs, and I look at the bases. The base over here, again, when it's not written, this is the common log, that is a base of 10. While on the other side, my log is also common log. That is also log with a base of 10. So using that property, we could say, all right, well, since the bases are the same, then whatever we're taking the log of must be equal to each other as well. So we have 4x minus 5 is equal to 2x minus 1. So now, since we're trying to solve the equation, we're trying to figure out what x is, I just went from an algebra 2 problem down to a basic algebra 1 problem. So I just have to solve it, and then we're going to check it. So I'm going to subtract 2x from both sides to get my x's together. So I get 2x minus 5 is equal to negative 1. I would add 5 to both sides next, and that would give me 2x is equal to 4. Divide by 2, and we get x is equal to 2. Before I box that and say, yes, this is my final answer, I do want to plug back in and check to make sure it works. It's a great habit. I know a lot of high school kids don't like doing it. Great habit to ensure you're doing something right. It's worth the time. So plugging the 2 back in, I'm going to plug it in for the x values. So that's going to look like log of 4 times 2 minus 5 is equal to log of 2 times 2 minus 1. So I just have to simplify the inside of the parentheses there. So I have 4 times 2 is 8. So I have 8 minus 5 on the left side. On the right side I have 4 minus 1. Do the subtraction there, I get log of 3 is equal to log of 3. Notice those we can now see are the exact same. So it works, so I know x equals 2 is my solution. My second example here, we're going to look at, well, what happens if we can't use that property? So I have log base 3 of x minus 3 is equal to 4. So again, we're trying to solve this equation. We're trying to solve for x. I have a log base 3 on the left side, but notice I do not have a log base 3 on the right side. So we cannot use that property before. So we're going to have to go back to kind of traditional ways of solving equations. So I would like to get this x all by itself. Right now I have a minus 3 with it inside of parentheses, and I have this log base 3. Now remember, when we're solving equations, we have to work the order of operations backwards, meaning we have to get rid of, addition, subtraction, multiplication, division, exponents, then parentheses. Remember that a log is an exponent, so I have to get rid of the log before I worry about the minus 3. So how we're going to get rid of this log base 3 is we have to use the properties of inverses. What I'm going to do is, notice how this is a base 3. I'm going to raise the left side and do an exponent and make it to the base 3. If I do it on the left side, I have to do it on the right side. Now this might be kind of hard to see, so I'm going to rewrite it. So what I did is I made both sides base 3. So I have 3 raised to the log base 3 of x minus 3. And on the right side, I have 3 raised to the 4th. The reason we are doing this is when the base here is 3 and the base of that log is 3, notice they're the same base, those are inverse operations. So we are left with x minus 3 is equal to 3 to the 4th power. Now, I just need to solve this. So 3 to the 4th power, that's going to be 81. Add 3 to both sides, I get x equals 84. Now, I'm not ready to box that. Again, I need to check and make sure everything works. Because what you're going to find, maybe not in this video, but one coming up, is it might not always work. So if I plug back in, I have log base 3 of 84 minus 3 is equal to 4. I'm going to simplify inside the parentheses there, so I have log base 3 of 81 is equal to 4. Now at this point it doesn't really look like these are equal, so I should probably figure out what log base 3 of 81 is. What I'm going to do there is I'm going to use change of base formula, so I'm going to figure out log of, using that change of base formula, log of 81 divided by log of 3 and figure out, hey, is this actually equal to 4? So log of 81 divided by log of 3, and I do get 4. So I have 4 is equal to 4, which, great, that all works out. So that means x equals 84 is my solution. And that was solving logarithmic equations. It's going to be the first of 2 videos on the topic, because there are a little bit tougher problems I need to show.